In this presentation, we're going to talk about the main content for this first unit of the course, truth tables. In the next series of lectures, we're going to sort of build up to what truth tables are meant to do, which is determine if an argument is valid or invalid. But to do that, we have to list out our rules for the different operators and then also explain how we determine validity based on the different values of the different sentences. But the next lectures will have these objectives. First, we'll introduce what truth tables are, and then we'll practice truth tables for a single sentence, and then finally we'll practice truth tables for a logical sequence. And then the idea will be identifying if it's valid or invalid, and a counter example will be needed if it's invalid. So here I want to briefly introduce what truth tables are for and outline some of the major points about them. So first thing is that truth tables are a way to check the structure of a logical argument. Like I said in the previous slide, we want to determine if a logical argument is good or bad. In this case, since we're doing deductive logic, we are looking for if it's valid or invalid. So each operator has a specific truth value based on the truth value associated with each of the propositions. So each operator has a left and a right side with the exception of the tilde. And depending upon whether the left side is true and the right side is true, or one's false and the other one's true, or vice versa, will change how that sentence is or what its truth value is. So we want to go through each of the different options for sentences for each individual operator, and then we'll build up to more composite sentences from there. And so truth tables contain any number of sentences. So each premise and the conclusion must appear somewhere in the truth table. So there will be a column for each premise and the conclusion. Sometimes your premises and conclusions will be a single letter, so they will automatically appear in the truth table, as you'll see here in the next couple slides after we introduce the rules. But the idea is that everything has to be accounted for in the truth table. So then when you go to check for validity, you have each of the determinations of the sentences visible to you. Here, what we'll see in not this presentation, because we'll hold off for validity and looking at arguments until the next presentation, but a sequent is valid if there are no instances in which all the premises are true and the conclusion is false. And so the opposite of that is that a sequent is invalid if there is at least one instance in which all the premises are true and the conclusion is false. And in that situation, a counterexample will be needed. Again, we'll wait to do validity in the next lecture, but it's just always good to bring it up here early on. I want to first introduce the ampersand rule. So what you'll see here on the screen is something very common, and it will show up every time that we do a truth table, which is this on the left-hand side. This is what's known as the key. These values are given to you automatically. And what you'll notice here are these values are supposed to represent all the possibilities of the combinations of true and false that the propositions can be. So here, P and Q are propositions. They also represent sentences, just single individual statements. And so what we have here are the different combinations that you could possibly have. You could have a situation in which they are both true. You could have a situation in which they are both false. You could have a situation in which one of them is false and the other one is true, or one of them is true and the other one is false. So this key shows up on every one of these slides, and as you see moving forward, because the whole idea for a truth table is to outline the possibilities of the combinations that go into a single statement. So each row represents a combination of truth values for the left and right side of an ampersand, namely this one right here. So what we want to do, as I erase some of this to make it a little bit easier to see, is we want to determine what the values of P and Q are based on each individual situation. So in this first row, what is an ampersand? An ampersand statement when both sides are true. Well, in that situation, the ampersand value is true. Now, moving on to the next one, what about when the left side is false and the right side is true? Well, in that situation, it's false. And then, moving on to the next one, situation in which the left side is true and the right side is false, it's false. And this final one, in which you have both of them false, the ampersand is false. Now this makes sense. So what we're doing here with the truth tables are we're asking ourselves, where is P and Q true? So if I were to tell you, let's say P represents pennies and Q represents quarters. Now, if I were to say this sentence that we're testing, that would be to say I have pennies and quarters. If I were to tell you that sentence, that I have pennies and quarters, well, where is that true? Well, it's only true where I have pennies and quarters. So saying the statement I have pennies and quarters is true when it's true that I have pennies and when it's true that I have quarters. If I were to say I have pennies and quarters in these other situations, like in this one, well, it's false that I have pennies. It's true that I have quarters. So saying that I have pennies and quarters, well, that's false because I don't have the pennies. And you can sort of see how this plays out with the other ones. Like here, it's true that I have the pennies, but it's false that I have the quarters. So saying something like I have pennies and quarters is false because I don't have the quarters. And then finally, the last one down here is, both of them are false. So if it's false that I have pennies and it's false that I have quarters, it's false for me to say that I have pennies and quarters. So that's why this one is only true, an ampersand is only true in which both of the conjuncts, the left and the right side, so each one, the P and the Q, represent different conjuncts. The P is the left conjunct, the Q is the right conjunct. Here, it's only true where both conjuncts are true. Moving on to the wedge rule, we have the same thing as we had last time. We have our key here. So we have P and Q listed individually, and we have the different combinations. We have they're both true, we have they're both false, we have one of them's false, and the other one's true, and the other one's true, and the other one's false. So we have all the different combinations of truth values between P and Q. So now what we want to do is determine the truth value of the wedge statement in which we are looking at P or Q. So here, it's pretty simple to guess some of these because we can think again of these as pennies and quarters. So say the P represents pennies, Q represents quarters. So I'm going to skip this first row because I think the middle two are a little bit easier to understand here. So in this situation, it's false that I have pennies, but it's true that I have quarters. So is it true that I either have pennies or I have quarters? Well, of course it's true, because I have the right conjunct here, the quarters, even though I don't have the pennies, but it says I have one or the other. Now looking at the next one, well, same thing here. It's true that I have the pennies. It's false that I have the quarters. But in both of these situations, it's saying I either have one or the other. Here I have the quarters, so it's got to be true. And this other one here, I've got the pennies, so it's got to be true. I got one or the other. Now here, in this bottom one, they're both false. So if I were to say I have either pennies or quarters, and it's false that I have pennies and it's false that I have quarters, that means it's got to be false because I don't have either one of them. One of them has to be true for it to be true. Now, the conflict here that we'll have, but we just resolve it right here, is that some of you might think, well, this is saying I have pennies and I have quarters. It's true that I have pennies and it's true that I have quarters. And this sentence is saying I have either pennies or quarters. There's a way in which you can read this as both true or false, mainly because the true version counts as an inclusive disjunction. So a wedge is just a disjunction statement. But us considering it true is an inclusive disjunction, meaning that it's fine if both of them are true. It only matters that one of them is true. Because it's true, I either have pennies or I have quarters. There's nothing that says I can't have both of them, but it's just saying I have at least one of them. Now the other side of this, making it false, would be to say, well, this is an exclusive wedge, saying that it says I only have one. I don't have both. I only have one of them. And so it would be false if we were saying, well, you can only have one, but not both. In this course, we treat the wedge as an inclusive disjunction, always. And the reason we do that is because an inclusive disjunction, it doesn't need any other input to be able to formalize it. We can easily formalize the disjunction, or the exclusive disjunction, such that it's false that we have both, by just using our simple formulation rules. So we could have P or Q, which says I have one or the other, but I don't have both P and Q. And that results into the exclusive disjunction. You don't have to be able to understand this right here. That's not a big deal. But this basically takes care of the situation which you want to say, well, what I really mean by an or statement is that I have one or the other, but not both of them. But as far as our rules are concerned, a wedge is true as long as one of the sides are true. That's the golden rule for the wedge. So let me erase some of this stuff, and then I'll hit the space bar so you can get the actual letters for it. So to go back through these, the values for each of these rows are, for the top one, it's true. For the second one, it's true. Third one is true. And the bottom one is false. And so remember that a wedge statement is false only where both sides are false. It's true as long as one of the sides are true. It's false where both sides are false. Now on to the arrow rule, or the conditional rule. So again, we've got our key. This is always the same. Yeah, combinations of true, combinations of false, false, true, true, false, always the same. So with our key, we're going to try to determine the value of this conditional statement. So it says, if P, then Q. Now I'm going to sort of change this up. P's and Q's are our usual standard letters that we use for just these introduction things. They're the ones that you always see. But what the P is going to represent in this situation is if it's raining, and then the Q is going to say, I'll take my umbrella. Just going to abbreviate umbrella there. I'll try to draw one so you know. There you go. So the P represents this, Q represents this, And so let's try to go through these and reason them out. So with this first situation, it says that it is raining, it's true that it's raining, and it's true that I take my umbrella. So if I were to say to you, if it's raining, I'll take my umbrella, it's true it's raining, it's true that I take my umbrella, so the statement itself that if it rains, I'll take my umbrella has to be true. Now if we look at the next one, and here's where it gets a little tricky. What it's saying is, it's not raining, but I did take my umbrella. So if I were to tell you, if it's raining, I'll take my umbrella, am I telling you a lie by saying if it rains, I'll take my umbrella when it's in fact not raining, but I did take my umbrella? Is there any lie in that? Your first inclination might be to say, well, yeah, because it's not raining, you took your umbrella, but that doesn't mean that this situation, the fact that it's not raining, doesn't mean that I can't take my umbrella with me. I might just take it with me in case every day, even though there is no forecast for rain, even though it's not raining currently, I'll still take my umbrella. So if I were to say if it rains, I'll take my umbrella, that's not invalidated by the fact that it's not currently raining. So in this situation, the statement if P then Q is actually true. So that situation is true. This next one, though, thinking about it, is to say it is raining, but I didn't take my umbrella. And in this situation, it's obvious that I'm lying if I say if it's raining, I'll take my umbrella, because it's true that it's raining, but I didn't take my umbrella. So here, in this third one, it's false. It's false because the left, or the antecedent, which is the P in this situation, so the P represents our antecedent, the Q will represent our consequent, but the antecedent, the left side, is true, so the condition is fulfilled, but the result doesn't happen. And in that situation, it's false. Now in this final situation, it's also a little bit tricky, a little confusing, because here it's saying it's not raining, I didn't take my umbrella. And you might think, well, they're both false, so this has to be false. But actually in this situation, the statement is true. And the reason the statement is true is because the left side is false. If it's not raining, we can't make any determination about whether my statement, if it's raining, I'll take my umbrella, is true or false. So it has to automatically be true, or there's nothing at least saying that it's false concretely. It can be true that if it rains, I'll take my umbrella. And in the situation in which it's not raining, I didn't take my umbrella, I'm not lying, I'm still telling the truth. And so in this final situation, it's true. The easiest way to remember this rule is that a conditional statement is true wherever the left side is false, the antecedent is false, or the right side is true. So in any situation in which you have a left if you have the antecedent is false, it's automatically true. Anywhere in which you have the consequent is true, it's automatically true. Doesn't matter if they're both one's false, or the left side's false and the right side's true, still true. So that's the best way of remembering it. Or you can also remember that it's false only where the left side's true and the right side's false. And again, that's because the condition was satisfied, but the results didn't come through. That would be the only situation in which the statement P arrow Q would be false. Next is the tilde rule, and you'll notice that there's only one letter here, and so there's only two rows because there's only two possibilities. There's only true or false for a single letter. There's no multiple combinations that we need. So in this situation, our key is very short. In most, actually almost all of the truth tables that we'll do, you'll always have at least 4 rows. And in that situation, what you'll have if you have a tilde is just a repeat of the same truth values. And so this, oops, this will pretty much just get copied into here. So both of these will be the exact same, which we'll just follow through and do that here. But so the tilde rule is pretty easy. If the key is showing a true, then it's false. And if the key is showing a false, it's true. And so in this situation, we can go back to the pennies example. So saying that the P represents pennies. And what this is saying is I don't have any pennies. So the tilde P is saying I don't have pennies. And so if we're looking at the state of affairs here in this possibility, it's true that I have pennies. So saying that I don't have pennies when in fact I have pennies is a lie. So that makes it false. And then the obvious reverse of it is in this situation, I don't have any pennies. It's true that, or sorry, it's false in the key. And so it gets flipped over to a true here just with the tilde. It's saying I don't have any pennies based on this key. And so it's true to say I don't have any pennies. And so just as I was saying before, we can just copy these values. So this is just going to be false and true. These just get duplicated down here. But the tilde is very easy. So a tilde is just taking the value that's in the key and flipping it over. And as we get more complicated, tildes can be outside sentences, so it just flips the whole value of the sentence. But we'll get to that as we progress. Finally, we have the biconditional or the double arrow. And so this one is also a little odd, and I'll try to give you the simplified version, and then I'll explain how these values sort of come about. So here, again, we have 2 sides. We have the P as the left biconditional and the Q as the right biconditional. We have the same key as we did before, and you can see all the different values. I won't circle all of them this time, but you'll just have to look for yourself that you got true, true, false, true, true, false, false, false. So those are all the different possibilities of combinations that we could have. So here is the easiest way to understand the values of the biconditional. A biconditional is true wherever both sides are true or both sides are false. So wherever they are matching, it is true. So here you have them matching. These are going to be true. Wherever they don't match, they are going to be false. So here you get a false true and a true false. So these 2 middle ones are going to be false, and the top and bottom one are going to be true. That's the easiest way of sort of understanding the double arrow. Now, the explanation for why this is so, you'll have to think back to your single arrow rules. So a double arrow of this sort can actually be written like this. This is ultimately what a double arrow is. It's saying that I have one conditional and that same conditional works in the opposite direction. And so thinking back to the arrow rule, well, we said it's true wherever the antecedent or the left side is false and the consequent or the right side is true. So one or the other, either the antecedent or the antecedent, the left side, is false, or the consequent or the right side is true. So if we think about it in these terms, well, the only situations in which this works out is where P and Q are both false. So that one would satisfy this group. And then the opposite, wherever these two are true, it would be true. So since you have those possibilities, it would have to be Q and P would both be true, or P and Q would both be false. And so that's how you get these values. Again, it might just be easier to remember that wherever they match, it's true. Wherever they don't match, it's false. But the explanation for why it's so comes from the fact that a biconditional is really just both conditionals joined together with an ampersand. But that is the final rule for the truth table. So now as we start moving forward, we're going to start looking at how multiple operators interact with one another. So here, what we have is just a truth table, and we have a single sentence on the right-hand side. So again, we've got our key. It'll show up every time on the left-hand side. You'll have all your different letters here. So we got P by itself, Q by itself. Those are the only two we'll see here. In the future, we'll have 3 letters, and so our truth table will be a little bit longer, at least more rows, but we'll hold off till we get there. But the difference between this one and the ones we just previously did when we were introducing the rules is the fact that we've got 2 operators here in this sentence. So we have an ampersand and a tilde. And so this becomes the important first step in doing truth tables, and that is identify the main operator. So just like with translations, it's important to be able to have parentheses to offset different operators, so and then we can make sure that the sentence is saying what we mean. Well, when we're doing a truth table and determining the truth value of different sentences, well, we have to be able to differentiate the order at which something happens. So it's just like in algebra, in which if you had something like 2 times 3 plus, let's say, 2, well, order of operations tells you that you have to do the multiplication first and then the addition second, and so your answer here is 8. But if you were to not have those rules, or say if you were to add in a set of parentheses here, well, then your answer is 10 because you have to do the parentheses first and multiply it like that. So just like in algebra, the order of operations matters, and so it's important to be able to identify the main operator. And what we'll want to do is we'll want to work from the smallest to the biggest. The main operator will be the last value that we do, or the last valuation that we make. And so here we've got 2 different ones. We have P ampersand tilde Q. And here, the main operator is our ampersand, because an ampersand has to have a left and a right conjunct. So here's my left conjunct, here's my right conjunct. And so the smaller operator here is the tilde. So what I have to do is I have to determine the value of tilde Q before I can do the value of P and tilde Q. So what I'm going to do here is I'm going to drop down some dotted lines. And what I'm going to do is I'm just going to do the evaluation of tilde Q by itself. So what's tilde Q? So we're going to ignore, we're just ignoring this part for right now. How do we evaluate tilde Q based on our key? Well, here it's true and true, so those trues will get turned into falses. Here it's false and false, so those will get turned into trues. Well, now we've done this operator. So this now becomes our right side. So I'm going to erase some of these markings. So using this as my right side, and I'm going to use this as my left side because that's my P. So P is my left side, tilde Q is my right side. I've done the evaluation of tilde Q here. Now I just need to compare left sides and right sides and then using the ampersand rule. So if you remember for the ampersand rule, an ampersand is true wherever both the left and right conjunct are true. And looking at our rows, the only situation in which we have that is right here. We're ignoring this one right here. We only worry about the true right here. We're ignoring the Q there in the middle. So the tilde Q is true here in row 3, and so is the P, so this one has to be true. Looking at these other ones, well, you have false and false, so that's got to be false. You have true and false, that's got to be false. You have false and true, that's got to be false. So again, what we're doing is we have to do the lesser operator, the smallest, we got to work from smallest to biggest, smallest one being the tilde here. So that's why we had to do this column, or yeah, this column first. And then we use this column and the P in our key to determine the actual value of the sentence, which is right here. I should have used a different color on that, which I will. Use yellow. So this column becomes the value for the whole statement. Now, when you take quizzes and do exams, the only one that we care about is this yellow column. I'm going to erase a bunch of this stuff because it's not needed. But what happens is this column over here that represents the tilde Q is only good for getting us this column in yellow, which is the value of the whole sentence. This column only represents tilde Q, which is not the sentence that we're looking for. We're looking for P and tilde Q. So it's just a small step in getting us to the final result, or the final values for the whole sentence. So we won't need these. We can get rid of them. Usually, I mean, if you write them out on paper, I just cross them out. But when you go to do the quizzes and the exams, the only column I'm interested in, the only one that we're interested in for determining validity and how the different sentences play themselves out, is this one right here. And so a completed truth table for this single sentence would be this. It would be the first row is false, second row is false, third row is true, fourth row is false. Now here in this next practice problem, what you'll see is we got two operators again. We have an arrow and we have an ampersand. And so again, the first step is always to determine what is the order of these operators. And so this one's a little bit easier than the last one because you see the sets of parentheses, which just like in algebra, anything in parentheses we do first. So the first operator we're going to have to concern ourselves with is the ampersand. So we can draw ourselves another dotted line here, knowing that we're just evaluating Q and P. We're going to ignore the left-hand side, the antecedent and the conditional statement. We're just going to concentrate on the conjunction, which is Q and P. So where is Q and P true? Well, just like on the last conjunction, well, it's true wherever both sides are true. And so here it'll be true, and in the rest of them it will be false because at least one side out of them is false. So after doing that, after doing just that conjunction, now we can move on to the full sentence. And we're going to use this column that we just created. I'll highlight it here in yellow. So we just created this one to evaluate the Q and P. And so we're going to compare this with our P because that's our antecedent. And so where is a conditional statement true? Well, conditional statement is true wherever the antecedent is false, or the consequent is true. And in these other ones, they're all false. So here we know that this top one has got to be true. Second one's got to be true. Third one is false. And the fourth one is true. So again, the rule for the conditional is if the left side or the antecedent is false, it's true, which is why we know this one's true and this one's true. Or the consequent or the right side is true, which is why we know that one's true. This one situation here in row 3 is the only one in which we have a true antecedent and a false consequent, so that's where it's false. And again, we don't need this column, so we'll just delete it. The only one we're interested in is this one that evaluates the whole sentence. So this column here evaluates this whole sentence here. The one column that we had on the right hand side only evaluated this, and that's not any good to us because what we're evaluating is the whole sentence, not just a single part of it. Now here in this next one, we have another instance in which we've got two operators and we have a set of parentheses, so that sort of makes it obvious that this is going to be our first operator that we got to handle, and then this one will be our main operator. So we got to do the arrow first, and then we can do the ampersand. So just like the times before, I'm going to draw some dotted lines, and I'm just going to ignore this whole right side for a second. I'm just going to focus on how do we evaluate P arrow Q. Well, just like before, we just finished another conditional statement. A conditional statement is true wherever the left side is false and the right side is true, or the right side is true. So in this situation, this one's got to be true because the right side's true. In the second row, the left side's false, so it's got to be true. Fourth row, left side's false, so it's got to be true. And also here, forgot to highlight that, in the second row, the consequent's also true. So in these 3 rows, it's true. In this third row, it is false because you have a true antecedent and a false consequent. So now with this, we've got our left side. Now we got to evaluate the whole sentence. So we're going to determine the value of the sentence based on the ampersand. This will be our left side now, and then P will be our right side. So we just have to imagine that these values for P are over here on the right side. So what we've got in this first instance is both of them true. And in that situation, an ampersand or a conjunction is true. In this next one, we have false and true, so that's got to be false. Remember, for a conjunction, if one of the sides is false, it's got to be false. And looking at these next ones, that's what we have. So for conjunction, both sides have to be true, which we only have that in the first row. And the other 3 rows, we don't have that, so they're going to be false. And again, we don't care about these anymore. We only care about this final row here on this side. So this represents the whole sentence right here. Moving on to the next one, we have P double arrow Q, wedge Q. So again, we have a parentheses letting us know that we have to do this operator first, and then we'll do this operator second because this one is our main operator. So we're going to ignore the wedge Q for a second. We're just going to determine what P double arrow Q is. We're going to drop down some dotted lines. again on the quiz and the exams. You won't have to do any of the dotted lines. All I'll be interested in is you'll just have to submit the value for the whole sentence. But when you're doing them in preparation to get to the final valuation of the sentence, it's just helpful to make these lines, I think. You don't necessarily have to do them, but I think it helps you visualize what's going on. So a double arrow, if you remember, is true wherever both sides are true or both sides are false. And in other situations in which they don't match, they are false. So with that, now we can evaluate the full sentence. So this column becomes our left side. The Q is our right side. So we just have to imagine that those Q values are over here on the right side, and then we're going to compare them. So where's a wedge true? Well, it's true wherever one of the sides are true. So one of the sides are true here, one of the sides are true here, one of the sides are true here. This is the only situation in which both the left side and the right side are both false. And so that's why it's false there. And so now we can erase all of this. We don't need it anymore. And so the truth values for each different combination for this single sentence up here at the top is true, true, false, true. In this problem, this is the first instance in which we've got three different operators. So we've got P, arrow, Q, and tilde Q. We've got three different ones. We've got an arrow, we've got an ampersand, we've got a tilde. So we got to determine what the main operator is. In this situation, I think it's easy to see that it's our ampersand because you have this as a left side. It's denoted by the parentheses. So the conditional is just operating over this P and Q inside here. And then this tilde Q is the right side of the ampersand. So the tilde Q or the tilde is just set over the Q. So we have to do both of those operators before we can do the ampersand here in the middle. So what we're going to do is we're just going to do one of these at a time. I'm going to drop down some lines like I have been doing. This one will be for our ampersand, this one will be for our tilde Q, this one will be for just our arrow. So this one's our arrow, this one's our ampersand, this one's our tilde. So I'm still going to do this one at a time. I'm going to just black out this so I'm not thinking about it. So P arrow Q, where is P arrow Q true? Well, it's true wherever you have a false antecedent or a true consequent. So it's going to be true, true, false, true. Now, before we can do the ampersand, we've got to do the tilde Q first. So let's ignore all of this. So for a tilde, we're just going to reverse the values. So this T becomes a false, this T becomes a false, this false becomes a true, this false becomes a true. So now, what we're going to use to evaluate our ampersand is this column here and this column here. So where's an ampersand true? Well, it's true only where both sides are true. So this one's going to be true, but in each of these other instances, one of them is false. Here, this one's false. Here, this one's false. Here's this one's false. So this bottom one is the only one that's true. So it's false, 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 true. And again, we're not interested in any of this extra stuff. The only thing that we're really worried about once you go to input it or determine validity is this one column representing the main operator. And so that's the one that we have left over. I just erase all of it so then you don't have to see it. But that's how you evaluate this one. Doing the lower operators first and then evaluating your main operator based on the left and right side. Now on this one, we have three operators again. So we got P or Q and Q arrow P. And I think it's obvious to see again that the parentheses offset one side and the other side. So your main operator here again is the ampersand. And before we can do the ampersand, that means we got to do the wedge and we got to do the arrow. So let's just do the wedge side first. So we'll just ignore all of this stuff here. I'll drop down some dotted lines. So where is a wedge true? Well, a wedge is true wherever one of the sides are true. And so we've got true, true, true. This bottom one is the only one in which both sides are false. Now let's focus on just the arrow. Dropping down some more dotted lines. So where's an arrow true? Well, here's where you don't want to get tripped up. Most of these have been not side specific, if that's how I want to phrase that. But don't get ahead of yourself, because the important thing here is that your Q is your left side and your P is your right side. So in all other instances of the arrow, we've been doing it such that the P is the left side and the Q is the right side. But here this one's slightly tricky, not meant to be tricky, but you have to be able to realize how to use the key. So the Q is our left side, or antecedent, and our P in this situation is our right side, or our consequent. So if you remember, an arrow is true wherever the left side is false or the right side is true. So Q being on the left side makes this one true, and P being on the right side makes this one true, and then this third row is already true, so it doesn't matter. So this second one is the only instance in which it says let me see what color combination I want to use, where the left side is true and the right side is false. And why this is the left side and why this is the right side is because that's how it's written here in this part of the sentence. So order matters specifically for the arrow. For the ampersand and the wedge, not so much. Even the double arrow doesn't really matter, but with the arrow, it does matter which side's which. So here, make sure you remember when you're looking at an arrow, you recognize which one's the left side and which one's the right side. So with that being said, this one's false. Now let's get to the full sentence itself. I'm going to erase some of this stuff. So now this is our left side. This is our right side. So an ampersand is true wherever both sides are true. So that means here in row 1 and row 3, it's true. Here in row 2 and row 4, it's false. So these are not necessary. We can get rid of them. And so your final evaluation for this sentence is true, false, true, false. Here again, we've got 3 different operators. And again, it's sort of offset with these parentheses, so it's a little bit obvious to see that the wedge is going to be our main operator here. So we'll do that one last. So we got to do the double arrow and the single arrow first. So let's just do them one at a time like we have been doing. So I'm going to block this thing off so we can just think of it not being there. So a double arrow is true wherever both of them are true, both sides, or both sides are false. So here in row 1 and row 4, they're true. In rows 2 and 3, they're both false. Or sorry, well, both rows 2 and 3 are false, but that's because they don't match. In row 2, P is false and Q is true. In row 3, P is true and Q is false. So true, false, false, true. Now with that, we can look at this arrow. So we're going to drop this down. We're just going to ignore all of this stuff over here. So where is an arrow? True. Well, it's true where the left side, in this situation, our P is our left side again. So wherever the left side's false or the right side's true. So true, true, false, true. Again, it's just easiest to remember that when it comes to an arrow, it's wherever, if the left side's false, it's true, or if the right side's true, it's true. The only situation in which the arrow is false is where the left side's true and the right side's false. So now with these two columns, we can evaluate the wedge. So the wedge is true wherever at least one of the sides are true. So that's going to be here, here, and here, because you have true, you have a true, you have a true and true. The only situation in which you don't have a true on either side is here in row 3, so that one's going to be false. And with this, we can erase all this again. And what we'll need is just this column right here. Now here's the first instance of a tilde in sort of an interesting position compared to where we have been seeing it. So here we've got 3 different operators again, and we've got different parentheses, some within the other ones. So we've got the 3 operators, we've got tilde, we've got an arrow, and we've got an ampersand. Now, it might be easiest to understand, well, the smallest operator is going to be the one that's within the most parentheses. Well, the one that's within the most parentheses is this ampersand right here. It's got 2, actually let me use a different color. It's got 2 here and 2 here. So this ampersand is within 2 sets of parentheses. So that's telling us we're going to have to do that one first. Next, if we're looking at parentheses, this arrow is within this parentheses and this parentheses, so it's within 1 set of parentheses. So that means it's going to be our second one that we're going to have to do. And so in this situation, this tilde is governing the whole sentence. The tilde is saying it's not all of this. So in here, this one's going to be our main operator, and so we're going to have to do it third. So this tilde is saying not this whole sentence, not this. But in order to determine the value of the tilde here on the outside, we have to make sure that we do this in the right order. We have to do the ampersand, which is within the most parentheses, and then the arrow, which is in the next set of parentheses, and then the tilde, which is outside all of the parentheses, saying that it's the main operator. In any situation in which the tilde is set outside of all the parentheses, out in the very front of however many sets of parentheses that you've got, doesn't matter, it's always the main operator. If you ever see the tilde on the far left hand side and there's parentheses starting it and ending it and they collapse down, it's the main operator. Now there can be situations in which you have some parentheses and then another operator and then another set of parentheses or just a single set. So the tilde governs as far as the parentheses go. So sometimes you just got to count to make sure how many forward-facing and backward-facing parentheses you have. And if there's just as many forward-facing and backwards-facing with the tilde in front of it that go all across the sentence, then you know that the tilde is the main operator. Most situations, it will be pretty obvious because the parentheses will be separated from one another, and you'll be able to determine the main operator just based on mainly intuition and the ideas that we've been doing this multiple times over, and it becomes a little bit easier to see where each one's the main operator. But with that, let's just do this sentence. So I'm going to erase all of that. So we have to make sure we do this in order. So we have to do this ampersand first. And so where's an ampersand true? Well, an ampersand's true where both sides are true. So it's going to be true here. And then the rest of these, it's going to be false because one of them is false. So with that, not too hard. Again, some of this will look really complicated, but as long as you do it step by step, it's really not that bad. It's just about following the steps, doing one thing at a time, and then building off of it. So now that we've done that, we can do our arrow. Let's erase this tilde. We're just going to ignore it. So the arrow is a combination of the P as our left side. Sorry, I didn't get all that in there. So P is our left side. This is our right side. So antecedent, consequent. If you remember, the conditional is true wherever the left side is false or the right side is true. And so here it's going to be true. Here it's going to be true. Here it's going to be false. And here it's going to be true. So in this situation, you just have to make sure you're looking at this as your left side, this as your right side, this you are ignoring because it's not telling you anything. And so that's how we get the evaluation here of the arrow. Now once we've got this arrow, we can actually go ahead and erase this because the only reason why we needed this was to be able to evaluate the arrow. Because the final thing that we're going to have to do is use the tilde rule on this column here. So really what the tilde is saying is it's not this conditional statement. This conditional statement with a tilde in front. And so since we have the conditional statement determined sans tilde here in this column, all we have to do is reverse the values of this column. So this T will turn into a false, this T will turn into an F, this F will turn into a T, and this T will turn into an F. So these are just flipping over to here. And so the value of the different combinations for this sentence is false, 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 or sorry, false, false, true, false. And we don't need those other columns because we had already completed everything else that we needed in order. But the idea or the main focus here is that you do these in order. You have to make sure that you start here, move here, using this first one, and then using this second one to determine this third one. So you have to go from first, second to the last. Here in this one, we have three operators again. In this situation, we have two tildes. So we have 1, 2, 3. And again, what we see is we have a tilde on the very outside of a set of parentheses. This is going to be our main operator. Now, we have to determine which one we have to do first within the parentheses. Do we have to do the arrow first or the tilde first? Well, in this situation, we have to do the tilde first because the tilde is only connected with this Q. So we got to work from the smallest to the biggest. So we're going to have to do the tilde first. And then we're going to have to do the arrow second. And then we'll have to do the main operator third, which is the tilde. So again, we're going to work from smallest to biggest and just go one at a time. So one at a time, tilde q. So all we're going to do is we're going to take these values of q and we're going to flip them around such that t's will turn into, actually I'm going to drop down some lines here real quick. T's will turn into f's and f's will turn into t's. And that's all we need for the tilde. Now we can do the arrow. I want to cross out this tilde here, so we're just ignoring it. So for our arrow, this is our left side, our antecedent. This is our right side, or our consequent. So where's an arrow true? Well, it's true wherever the left side is false or the right side is true. And so in these situations, it will be true, true, true. And in this top row is the only one in which it will be false, because you have a false left side or a false antecedent and you have a true antecedent and a false consequent. So now with this, we can eliminate here, eliminate this column, because now we're just going to take this column, which represents the arrow statement, and we're going to fill in our tilde, which is here on the outside. And just with the other tilde, all we're going to do is flip the values that we have associated with the arrow. So f will turn into t, t will turn into f, t into f, t into f. So these values just get flipped like so, and the value for the whole sentence then is TFFF. This is the last one we'll do for this video, but as you can see, we have 3 letters this time, and in most truth tables that we will do, you will see 3 letters. So 3 different letters means that we have to have more possibilities, which is why we have more rows. Here we'll have 8 rows, and if you look closely, you can see a pattern. The P goes true, false, true, false, true, false, all the way down. The Q goes true, true, false, false, true, true, false, false. And then the R here goes true, 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 false, 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 false. So there's actually a pattern here in which you have alternating 1 at a time, 2 at a time, and 4 at a time. If we had a 4th letter, you would have 8 trues and 8 falses, and it would be 16 lines long. So we won't go that far into truth tables. That's a lot of work, so we usually stick to 2 or 3, and at least here at the lower level. And so, but that's why you see a much larger key here than what we've had in previous instances, because we have to make sure we have all the different possibilities, all the situations in which P, Q, and R could be of different values. And you could see, here in the top, they're all true. Here at the bottom, they're all false. But in all these other situations, one of them's false, some of them are true, some of them some of them are true, some of them false. But all the different combinations are taken care of within our key. So with that, we got to do the same thing as we've done before, which is we have 2 operators here, and the first thing we want to make sure we do is recognize what our main operator is. In this situation, it should be pretty obvious again that our ampersand's our main operator because it's outside the parentheses. You have the P as your left side and the Q or R as your right side. So that means we got to do our wedge first, and then we got to do our ampersand second, because that one is our main operator. So let's drop some dotted lines here. Let's block this off so we can just ignore it. And so even though we have 3 different letters here, we're only evaluating Q or R. So, ignore that P is even there. That's doing us nothing in our key because we're not evaluating it. We're only using Q or R. So where is a wedge statement true? Well, a wedge statement's true wherever one of the sides are true. One of the sides are true, 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 and then in these last two rows, they're both false. So we know it's true, 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 and false, false. So it's false because both of them are false here and both of them are false here. A wedge is true as long as one of the sides are true. If both sides are true, that's totally fine too. As long as one of them's true, it's true. So now that we've got that, let's erase this. Let's bring the ampersand back into the fold. And so now, this is our right side. This P is our left side. And so we're evaluating the ampersand. Where's an ampersand true? An ampersand's true wherever both sides are true. Both sides are true. Both sides are true. Both sides are true. And that looks like all of them. So, first row, true. Second row, false. Third row, true. False, true. And false all the way down. The reason they're false is because at least one of them is false in each of these different lines here. Oops. Only row, let's see, 1, 3, and 5 are true because those are the only ones in which they're both true. Now, if you remember, we can erase all this stuff. We don't need it anymore. The value for this sentence based on our key is this. So this one column is the only one we need. We can get rid of the one that represents the wedge because it doesn't give us any information that we actually need. So that concludes this lecture on truth tables. In the next one, we'll do a little bit more recap with just single sentences, but then we'll move on to actually determining sequence and figuring out if they're valid or invalid. If they're invalid, we'll have to figure out a counterexample, and that is truth tables in a nutshell. But until then, see you then.